Can you guys hear me? Hello? Yes? All right. All right. So thank you, Nicole. Moving on to our second session, allow me to introduce myself. My name is Craig Dinwong from SPE-UTM SC, and I will be the moderator for this session. The theme for our session would be CCUS as a remarkable solution to support emission reduction, brought to you by Ms. Mutia, Kharunisa, Mardhatillah. Before we begin, allow me to introduce you to our speaker. Is there any slide sharing? All right. So just a short introduction about our speaker today. She has a master's degree in petroleum engineering from Universiti Teknologi PETRONAS and is currently a carbon capture and storage researcher. Nevertheless, she has many more other experiences, as you can see on your screen. And without further ado, let's start this session, shall we? And with that, I'll pass it to Ms. Mutia. The floor is yours. Is she here?
All right, thank you, the moderators. Can you hear my voice?
Yes, yes.
So, okay, please spare me some time to upload my slides. All right. Okay, so we can start now. So, okay, thank you for the host for the invitation. So, Assalamualaikum and a very good day. I back to audience from SPE-UTM SC, SPE-ITS from Indonesia, and SPE-PSU from Philippines. As shown in the opening slide, today I'm going to present a topic which is on the CCUS as a remarkable solution to support emission reduction. For in the introduction, I would like to repeat about myself. So I'm a research assistant under PETRONAS project, which focusing on the CO2 injectivity change in Selang Aquifer. I just graduated my bachelor degree in petroleum engineering last April 2022 and currently pursuing my study in Master of Science in Petroleum Engineering by research. So my research team is related to the CO2 brine rock interaction mechanisms after the CO2 injection. So if you want to know further about my project or my study journey in CCS, you might keep that question for our Q&A later. So throughout this presentation, I encourage you to ask questions and share your own thoughts and experience. So I believe that the best way to learn and grow is through open dialogue and exchange of ideas at the end of the presentation. So without further ado, let's begin the lecture for today. So next slide. All right. So in this section, I would like to emphasize the objective of today's sharing session, which includes the explanation of greenhouse gas emissions and methods to reduce them. Next, to overview the carbon capture, utilization, and storage, which this will be the main of our today's chapter. And lastly, to review the obstacles to implement the CCUS and propose some advancement on the CCUS. So let's moving on to the next slide. All right, so this will be the outline of today's sharing session. As mentioned earlier, first I'll be sharing about the greenhouse gas emission in part 1, which include the types of greenhouse gas emission to the atmosphere and ways to minimize their emission in oil and gas industry. Next, I'll be talking about the CCUS, which involve the urgency needs of CCUS, which are related to the factors that lead to the CCUS implementation. Also, the overview of the CCUS and the CCUS in Malaysia. And then I'll be sharing about the obstacles in the development of CCS and its implementation in general, and also proposing few ways to advance the CCUS implementation in the world in order to achieve our target to reach the net zero carbon emission by 2050. Next slide. All right, so next slide, I guess. Okay, so the oil and gas industry is a significant source of greenhouse gas emission, which contributes to the climate change. The main types of emission produced by the oil and gas industry are carbon dioxide, the methane, and the nitrous oxide. Here's how each of these emissions can be reduced. So as for carbon dioxide is produced by the burning of fossil fuels, which is the primary activity of the oil and gas industry. One of the way to reduce the CO2 emission is to capture and store the CO2, which is known as the carbon capture, utilization, and storage, which is the CCUS. This involves capturing the CO2 before it's released to the atmosphere and either storing it underground or using it for other purposes. Another way to reduce the CO2 emission is to increase the energy efficiency by optimizing the processes and the equipment, which can reduce the amount of fossil fuels that are burned. Next, for methane. Methane is a potent greenhouse gas that is produced during the extraction and transport of oil and gas. Methane can be reduced by using the leak detection and repair programs to identify and fix the leaks in equipment and the infrastructure. Improving the equipment and the infrastructure, such as using the low emission technologies, can also help to reduce the methane emissions. Next, as for the nitrous oxide. So nitrous oxide is actually produced during the certain oil and gas production processes, such as the combustion of fossil fuels and the use of nitrogen-based fertilizers in oil palm plantation. Reducing the use of nitrogen-based fertilizers and optimizing production processes can help to reduce the nitrous oxide emissions. In addition of these emissions, the oil and gas industry is also a significant source of air pollutants such as sulfur dioxide and nitrogen oxide. These pollutants can be reduced through the use of low emission technologies such as flue gas desulfurization system and the selective catalytic reduction system. So moving on to the next slide. All right, so there are several methods that can be used to reduce the emissions in the oil and gas industry. So here are some examples. For first, the carbon capture, utilization and storage, CCUS. This method involves capturing CO2 emission before they are released to the atmosphere, then either utilizing or storing the captured CO2. The utilization involves finding ways to use the CO2 such as for enhanced oil recovery or in industrial processes. So the storage also involved in storing the CO2 in underground geological formation. All right, so next, for the energy efficiency improvements, the oil and gas industry can reduce its emission by improving the energy efficiency of its operations. This can include measures such as using more efficient equipment, optimizing the processes, and reducing the flaring and venting. So next, the renewable energy integration. The oil and gas industry can also reduce its emission by integrating the renewable energy sources such as the solar or wind power into its operation. This can help to reduce the amount of fossil fuels that are burned and overall reducing the emission. Another way is also we can reduce the methane reduction. So methane is a potent greenhouse gas, and the oil and gas industry is the methane can be reduced through measures such as the leak detection, as I mentioned before. And by using the low emission technologies, we can significantly reduce the methane reduction. All right. So we can use also the alternative fuels. So the usage of alternative fuels such as the natural gas or biofuels can also help to reduce the emissions in the oil and gas industry. Last but not least, the operational changes. So the operational changes such as reducing the amount of water used in the production processes, reducing the amount of chemicals used in the production, and optimizing the transport or logistic that can help in reducing the emission. So basically, operation changes is related to how we optimize the operation in order for us to reduce the emission of the greenhouse gas, right? So overall, there are a variety of methods that can be used to reduce the emissions in the oil and gas industry. The most effective approach will depend on the specific circumstances and characteristics of each operation, and a combination of different methods may be needed to achieve significant emission reduction. So basically, how we reduce the emission would be depends on the circumstances itself and how the operation is working. So yeah, so that's pretty summarize the type of emission and the ways of us reducing the emission of greenhouse gas. So we can move to the next slide. Okay, so basically we have done with part 1. Now we are entering part 2, which is on the carbon capture, utilization and storage, CCUS. Next slide, please. Alright. Okay, so as mentioned earlier, the first subtopic for this part is about the urgency needs of CCS. So basically in this topic we will cover what are the factors that lead to the needs of implementation of CCS. Right, so one of it is the carbon dioxide itself. So the carbon dioxide is classified as one of the main contributor for the greenhouse gas emission. So the carbon dioxide is an anthropogenic gas that absorbs and radiates the heat. So this responsible for about 2/3 of the total energy imbalance that cause the Earth's temperature to rise. Second, so due to the industrial revolution, ever since industrial revolution era began around 1750, human activities have contributed substantially to the climate change. So I guess this is has been covered by our first speaker. So I just quickly recap again. So the human activities that contributed to the climate change is adding the CO2 and other heat-trapping gases to the atmosphere. So by 2020, about 79% of CO2 from greenhouse gas emissions in US contributed by human activities. So as shown in this figure 1, this figure shows the distribution of CO2 emissions at various human activities, which includes the transportation, the main contribution of the CO2 emission, which with the proportion of 33%. So basically, transportation is, you have to know that it involves with the combustion of fuel. So that's how it contribute much much in the emission of CO2. All right, so next is on the electric power, which contribute in 31% of the emission of CO2. Another one is the industry. It contribute around 60% of the CO2. And another one is the residential and commercial, which contribute 12%. And another is non-fossil fuel combustion, which involve around 8% of CO2 emission. So we can move to the next slide. All right, okay. So next, CCS is required to be implemented due to the rise in CO2 emission. In Jan 2023, atmospheric CO2 levels have reached around 419 ppm, which is a 50% increase over the 7050s to 800 average. So the human-driven CO2 rise in halfway towards the double CO2. So if global energy demand continues to grow and to be mostly with fossil fuels, atmospheric carbon dioxide is projected to exceed 900 ppm by the end of century. So this is worrying the world, because by increasing the carbon dioxide level at the atmosphere, it could lead to further damage on our Earth, basically. So this figure 2 show the carbon dioxide level since the pre-industrial year. And as you can see, if you compare between the pre-industrial industrial revolution era and current 2020s, the level of CO2 is almost double. So it is pretty worrying for the world actually. So we can move to the next slide. Alright, so let the video play. So I will explain why the video is showing how the global average temperature has been increased ever since the industrial revolution up to 2020, right? So with the increase of the CO2 emission, this heat trapping gas has significantly increased the global average temperature. I would like to share you have you seen in the video, like you'll be surprised with the fact that how much our Earth temperature has been increasing rapidly up to today. So no wonder we feel much hotter. And right now we have been hearing a few implications such as the melt of ice from certain countries, right? So for your information, as for 2022, the average global temperature of Earth has reached up to 1.6 degree Fahrenheit, according to NASA. So you can further increase you can speed up the video, I guess, to show like how the current temperature has been in 2020. Right. So this is the picture of 2022. As you can see, most of the globe is covered in red temperature compared to the earlier industrial revolution. So this pretty like become the urgency for us to implement the CCS, which to capture the CO2, because the more we release the CO2 towards the atmosphere, we will further increase the temperature and more damage will be done towards the human itself. So moving on to the next slide. All right. So another factor that lead to the urgency needs of CS is due to the CO2 emission increment. So this also increased the global mean sea level. So provides an integrative measure of the state of the climate system. So basically, the global mean sea level is providing the integrative measure of the state of climate system, such as the ocean and cryosphere, and indicates of what is happening to the climate in the present and what may happen in the future. So the factors for this increase of mean sea level is due to the added water from melting ice sheets and glaciers, and the expansion of seawater as it warms due to the increment of the global temperature. Hence, the implications of this global mean sea level increase, the world's population predicted to be around 11 to 12 billion people by the end of the century will be exposed to the heat wave every year, and 120 million people will be directly affected by the river flooding, and 2 billion people will be exposed to difficulties to access water, and land available for the growing crops will reduce by the equivalent size of the country like Australia. So next, moving on to the next slide. So we have covered the factors that basically involve in CO2 emission, right? So due to this, there is Paris Climate Agreement have been introduced to mitigate the CO2 emissions. So have you ever heard about this Paris Climate Agreement? Anyone? Please, you can open your mic to answer.
Yes, I've heard about the Paris Climate Agreement before.
So maybe you can answer what is the Paris Climate Agreement in the chat box, just to make more interactive section for this lecture. So what do you think? What is the Paris Climate Agreement actually?
Well, I think before the SPEs is created, before it is about the Paris Agreement, I think it is to reduce the carbon emissions, to having a sustainable development. Yeah, I think that's kind of the Paris Agreement.
So what is your answer for this question? A, B, or C?
I think it is wait, I need to take the moment. I'm sorry. I think it is B, because it's like an international agreement.
All right. So thank you for participating in this pre-assessment. So we can move on to the next slide. So basically, the answer is correct. The answer is B. Okay, so I would like to further discuss about what is Paris Agreement enforcement actually. The CCS is to be implemented due to the Paris Agreement enforcement. So this will be the main game changer for the needs of CCS actually. So by the Paris Agreement is actually legally binding international treaty on climate change. So basically, this is adopted on 12 December 2015 and entered into force on 4 November 2016. So this Paris Agreement is enforced with a goal to limit the global warming, but to well below 2 degrees 2 degrees Celsius, preferably to 1.5 degrees Celsius compared to the pre-industrial level. So as for now, based on what I have researched on, our current temperature is at 0.89 degrees Celsius. So the based on the Paris Agreement, we want to limit the global temperature up to like below 2, so preferably to below 1 to be 1.5 degrees Celsius. So to achieve this long-term temperature goal, countries aim to reach global peaking of greenhouse gas emissions as soon as possible to achieve a climate neutral world by the mid of the century. So which is in order to avoid the worst impacts of the climate change and preserve a livable planet, and to keep the global warming to more than 1.5 degrees C, the emission needs to be reduced by 45% by 2030 and to reach the net zero carbon by 2050. So to put simply, the net zero means cutting the greenhouse gas emissions to as close to zero as possible, with any remaining emission reabsorbed from the atmosphere by oceans and forests, for instance. So to give you a clear overview, what is actually Paris Agreement in summary is actually this agreement enforcement is actually a policy to all the countries in this world to align with to reach the net zero carbon emission by 2050. So each country plays a role at their own country on how they will reduce the CO2 emission. So one of the ways is by using the CCS, because CCS is one of the largest like it can store more CO2, like tons and millions of CO2 underground. So with that high storage, we will be able to permanently store the CO2, and we can reach the net zero carbon emission. So you might thinking that, oh, net zero carbon emission, does it mean there is no more CO2 in this world? That is a wrong perspective. Actually, what does it mean by net zero is when you release the CO2, you either you utilize the CO2 or you can inject back the CO2. It's not mean we are not producing CO2. The CO2 produced, we re-inject the CO2 in the underground. That means what the amount that we release, the amount that we keep in store in the permanent in the deep underground geology is almost the same, which means that's why the amount is released and the amount is stored is balanced. That means there is no excess CO2 is on our atmosphere, because we already capture the released CO2 by storing it underground, or we utilize the CO2 for another purposes. All right, so so we can move to the next slide. Okay, so here's a few examples of efforts proposed by developed countries to align with the Paris Agreement. So as for China, China announced to strive to achieve carbon neutrality by 2060. The country will adopt more vigorous policies and measures to peak emissions before 2030. So also for Germany reached its 2045 net zero target in law in June 2021 after raising its climate ambition. The cabinet adopted a 65% emission reduction by 2030 and 85 to 90% by 2040 and net zero emission by 2045. As for United Kingdom, Scotland's devolved parliament is working on a bill to reach net zero in 2045 based on its strong renewable energy resources and capacity to store the CO2 in depleted North Sea oil fields. So next slide, please. Alright, so next I would like to share with you the Malaysia's energy initiative to achieve the net zero carbon emission. Our government has introduced a plan known as 12 Malaysia Plan, 12 MP, which consists of following four main things. So the first one, no new coal power plants. So the government will no longer build the new coal-fired power plants. So cleaner electricity generation will be implemented through the operation of several gas power plants in Peninsular Malaysia to replace the coal-fired power plants. So next, the economic instruments such as the carbon pricing and carbon tax will be implemented. So basically, from what I have discussed with my supervisor, this carbon tax in Malaysia has been finalized and will be implemented soon. So next is the blue economic frames. So this is provided to determine the development direction of the coastal and marine areas. And lastly, the government gives priority to the development of energy efficient vehicles, which is the electrical vehicles, production industry to support the environmentally friendly mobility initiative. So next slide. All right. So also due to this mission to achieve net zero carbon emission, here's the PETRONAS aspiration to accomplish them. So PETRONAS is our national oil and gas industry. Yeah. So first is the aspiration is to build on operational excellence strengths, which to reduce the hydrocarbon flaring and venting, capture the methane emissions, and optimize the production in operations. The second is to mitigate the greenhouse gas emissions from operation through energy efficiency improvement and use low carbon or renewable energy. Next, the aspiration is to make cleaner energy more accessible by increasing the efficiency in providing low carbon energy and solutions such as the natural gas and renewable energy. Then to accelerate technology and innovation stewardship, which to develop the low and zero carbon fuels, products and solutions. Also to advance the emission reduction technology such as carbon capture, utilization and sequestration, which is CCUS, in the high CO2 gas field. Lastly, to invest in nature-based solutions, which to preserve and restore the capacity of ecosystems to act as forest-based carbon sinks for CO2 sequestration. Next slide, please. So now you are updated with the factors that lead to the implementation of CCS, which is involved in the CO2 itself, the rise of temperature, the rise of CO2 level and the global mean sea level. So now that factor that lead to the CCS, right? Now, so we can now cover what is CCS actually, or we can call it CCUS. So basically CCUS is the acronym of four processes such as carbon capture, the utilization, and storage. So let's now talk about how CCUS works. So the first step is carbon capture. So carbon capture technology is used to capture the CO2 emission from industrial processes such as the power plants, the cement factories, and the steel mills. So there are several types of carbon capture technology such as the post-combustion capture, pre-combustion capture, and C-fuel combustion capture. So once the CO2 is captured, it will be transported either using ship or pipeline, and then it will be converted into products or materials known as the carbon utilization. So there are several ways that CO2 can be used or converted, including the production of biofuels, the production of chemicals and materials, and the production of building materials such as concrete. So all the CO2 that is cannot be used or converted for the utilization, the remaining CO2 can be stored underground in the geological storage sites. So this is known as the carbon storage, or people also sometimes call it CO2 sequestration. So the CO2 is injected into underground storage sites where it is stored in the such as depleted oil reservoirs, the slime formations, and deep coal seams. So we can discuss this on the next slide later on. Right, so next slide, please. So, okay. Here is the global CCS map that shows the CCS project around the world. So you can refer the source to discover further and get to know the status of this CCS field that has been operated through in this world basically. So you can just search this Scottish carbon capture and storage to further find out that how many wells that have been injected of CO2, what is the status. So yeah, so we can move to the next slide. Alright, so now I would like to introduce you about CO2 storage, or we can call it CO2 sequestration. So basically we store our CO2 in the deep underground geological formations, as I mentioned before, right? So this deep geological sequestration shows. Okay, so figure 6 shows the cross-sectional diagram of underground CO2. So this is the source from Benson and Co 2008. There are three key components of CCS technology which aims to capture CO2 from industrial processes and store it safely underground. So the three key components includes the CO2 containment. So the first one is CO2 containment, which involved in the cap rock integrity to prevent from the CO2 to be leaking after we inject the CO2. So how we can ensure the injected CO2 is permanently like stored inside the formation in not leaking. So that's we control it through the CO2 containment. So the next one is we need an adequate storage, which also known as the CO2 storage. And last one is the CO2 injection, which involved in the near wellbore reaction. All right. So next slide, please. All right, can you go back to the previous slide? Actually, I have added one slide in my current slide, but it's okay. I'll just share with you. So as you can see in this figure, for the CO2 injection near wellbore reaction, so that is actually we can read it further about CO2 injectivity, as this is my research area. So I would like to share a bit. So for your information, as for saline aquifer, once we inject the CO2, two mechanisms will happen simultaneously, which are the mineral dissolution and mineral precipitation. So this is due to the interaction between the injected CO2. So basically the CO2 is pretty reactive, and so once we inject the CO2 inside the formation in saline aquifer, we have the in situ brine and the formation rock, right? So the injected CO2 will react with the brine as well as the rock. So this interaction has lead to the petrophysical properties change, such as the permeability of the rock due to this the dissolution and the salt precipitation. So I guess because after this mechanism happened due to the dissolution and salt precipitation, which eventually lead to the permeability change, this will clog the pores. Okay, as for example, for the CO2, like for the mineral dissolution, the CO2 will dissolve the cementing materials that hold the grains between the materials, right? So once the cementing materials has been dissolved, the grains that initially attached with the cementing materials will be released, which this also known as the fine migration. So as for the salt precipitation, this is happening due to the drying out effects, because once we inject the CO2 inside the saline aquifer, the brine start to evaporate due to the CO2 presence, and once the brine evaporates, there is only salt left, and hence this causes the salt precipitation to happen. So due to this salt precipitation and fine migration, this lead to the permeability reduction, which eventually will lead to the formation damage. So that's why we need to control this CO2 injectivity reaction to make sure that there is no damage basically when we inject the CO2 on or like how we can control the permeability change by due to this mechanism basically. So that's pretty summarized my research on this area. So next slide, please. So here are some studies that can be explored according to each CCS key components. So as for CO2 storage or capacity, you can study the sedimentology and depositional model for volume connectivity and so on. So as for CO2 injectivity, you can study the reservoir connectivity and probability. That's what I did for my research, and geomechanical or geochemical analysis and dynamic reservoir modeling. So lastly, the CO2 containment for trap and seal. Integrity include the cap rock characterization and analysis. So basically, there are three different areas related to the CCS, the capacity, injectivity, and containment that you can explore further. Is in case you are interested to do research in CCS, because currently CCS is basically still in development. That the status is under development. So there are there's still much area that can be improved. So here are the areas that you can actually further if you are interested to do your research in CCS area. So next slide, please. All right, so I would like to share with you the CCS project in Malaysia. So here is the map of Malaysia's CO2 storage site. So more than 46 tera cubic feet of storage capacity has been identified, and it is ample to cater for upstream CO2 emission in Malaysia. So this is the source from PETRONAS website. So you can refer it if you want to know further about this one. So we can move to the next slide. All right. So so actually this is the first CCS project in Malaysia, which is the Kasawari field. So basically Kasawari field is a high CO2 content gas field, so located in Sarawak. So it is operated by PETRONAS Carigali. So the field that we are going to produce, the gas field that we are going to produce is from the Kasawari. And based on from the CO2 that is being produced after we recover the gas from Kasawari field will be transported to the M1 field. So actually this M1 field is the depleted gas reservoir that already produced before. So the CO2 that we produce from Kasawari, we transport it to the first we have to process the CO2, right? So we produce it offshore, and then we transport the CO2 to the M1 field using pipeline. So we inject the CO2 back in the M1 field in the depleted gas reservoir. So that the picture is showing like how the transition from Kasawari to the M1 field. So the technology that PETRONAS deploy in the CO2 capture and storage in this project includes the PN2 hollow fiber membrane, cryogenic distillation for high CO2 concentration, supercrop corrosion prediction software for supercritical CO2, and the CO2 storage simulation. So I would like to share with you what are the difference between the conventional well that we produce for gas or oil, and the CO2 CCS well. So basically the difference between the well is based on the materials that we use for the well, and the cementing materials as well. Because as for CCS well, we are injecting CO2. As you know, CO2 characteristic, it is very corrosive, and for that we need different materials that is specifically used for CO2. So basically that is the only difference between the normal well and the CCS well. All right. So and for your information, in this technology, on the third technology, it's mentioned about supercritical CO2. So maybe you have heard what is supercritical, but I will just share with you. So basically, due to the different pressure and temperature, right, we have the phase envelope. So for example, for any pressure that is above 1030 psi and temperature above 31.1 degree C, the CO2 will be in supercritical state. So, and there is a few classification for the phase to be in gas or liquid. So basically, during the injection, we inject the CO2 in the high temperature and high pressure field. So no matter how you decide at first, you want to inject gas CO2, for example, in the end, this gas will be converted into supercritical condition. So that's why initially before we inject the CO2 inside our field, we usually inject in supercritical condition. Because usually in the formation itself, due to the change in temperature and pressure, no matter what, the CO2 will always be in supercritical condition. So that's what is the supercritical condition for your information. So next slide, please. Alright, so this is the second CCS field in Malaysia, known as Lang Lebah field. So this one is a bit different compared to Kasawari field because both are high CO2 content gas field. But as for Lang Lebah, we need a special need, which is to remove the hydrogen sulfide contaminant. So Lang Lebah field also located in of course Sarawak, and it is actually operated by PTTEP, a Thailand company, along with its partner which is KUFPEC and PETRONAS Charigali. So basically, our gas field is the Lang Lebah, and from the Lang Lebah, the CO2 that is produced will be separated onshore. So that is the difference between the Kasawari and Lang Lebah CCS field. So for Lang Lebah, we process the CO2 at the onshore platform. Then only we inject back the CO2 that has been separated to the Golok field. So the Golok field is the depleted gas reservoir that is used to store our CO2 basically. So okay, so due to the hydrogen sulfide contaminant, so Sarawak integrated sour gas evacuation system is used as a catalyst to monetize the high contaminant field in this Lang Lebah CCS project. Okay, so that's our current update for CCS project in Malaysia. Basically, we have two CCS field. So, all right, so we can move on to the next slide. Okay, so we already talked about the CO2 storage. Now you already get the overview that CCS involved in storing the CO2 inside the underground geological formation, permanently store the CO2 inside the formation and all that. But also CCS, we have the U acronym, right? So the utilization. So one of it is enhanced oil recovery. So as you can see in the picture, once you inject the CO2 inside our, for example, depleted gas reservoir, that as what we did for the Kasawari and Lang Lebah CCS field. So once we inject the CO2, somehow in the depleted gas reservoir, we have the remaining gas that is left after we produce, right? So this remaining gas or oil that has been left inside the formation, when we inject the CO2, it can somehow help in extracting this remaining oil or gas. So that's why we call it CO2 EOR. So because we know, right, the CO2 is one of the methods to enhance the oil recovery. So you are involved in injecting CO2 into oil reservoir or gas reservoir to increase the oil recovery. And the CO2 helps to reduce the oil viscosity, making it easier to extract. So basically, there is a common technique that is used to increase the production and extend the field's life. So basically, you have two things when you inject CO2 in depleted oil and gas reservoir. When you inject, you can store the CO2 as well as you can somehow produce the remaining gas or oil that left in the formation. So that's how maybe you can make profit somehow. So that is one of the current things on the CO2 utilization, which is the EOR. So next slide, please. So another CO2 utilization is the processes. I categorize them into the processes. So the first one is the mineralization. So the CO2 can be reacted with minerals to form stable carbonates that can be used in various applications such as the construction materials. And also the CO2 can be used as a feedstock for chemical synthesis, such as the production of urea, which is used as the fertilizer. And the third one is the algae cultivation. So the CO2 can be used as the feedstock for algae cultivation, which can be used for various purposes such as the biofuels or animal feed, basically. So that's how we can utilize the CO2. There's a few other utilization we can implement for the CO2. So I just choose three for this topic. Okay. So we can move to the next part. Next slide, please. All right. Okay. So the last part of today's lecture is basically the obstacle and the advancement of the CCUS implementation. So next slide. All right. So the challenges in implementing in CCS and its implement involved in I summarize them into stages. So the first one is CCS is pretty high cost. So capturing CO2 from industrial processes, transporting it, storing it underground requires significant investment in infrastructure technology, and also this CCS technology is still in the early stage of development. So it needs to be scaled up and requires significant investment in research, in the development and demonstration. That's why as for now, Pasabari is actually to be operated in 2035, 2025. Okay, another 2 years. So as for now, we are still in early stage, which we still develop the infrastructure, and it require pretty long duration actually to inject the CO2 to the underground. So that's why we need to scale up them. So another one is the energy consumption. So this CCS actually require a significant amount of energy to capture and transport and store the CO2. So also CCS there is lack of clear and consistent regulatory frameworks for CCUS technology, which creates uncertainty for and risk for investors. So government needs to create supportive policies and regulations that can incentivize the investment in CCUS technology. So like how we can actually get um, incentive by doing the CCS. So okay, so basically, as for your information, actually we can get the revenue based on the CCS. Maybe what we can introduce is the carbon tax. For example, if we have the CCS field in our country, maybe from the developed countries, they have many CO2 that they want to store. They can store it in our field, but we can charge them, for example. That's how we make business based on the CCS. But this is pretty not clear yet, and it is varies based on the different countries basically. So another one is the public acceptance. So the public acceptance of CCUS technology is still low. So basically, if you ask the random people, do they know about CCS? Basically, not everyone know about CCS, right? So this is the challenge for us to implement the CCS. So this can create the social and political barriers due to its development and implementation. So for the long-term storage, actually there is a risk that the CO2 could leak back into the atmosphere. Like how certain we are that the CO2 can like stay in the underground. So that's why monitoring and verification systems need to be in place and to ensure that stored CO2 is secure and does not pose any risk to the public health or the environment. So that's why we really need a good research and like a pretty good development before we actually executing the project. Okay, so the last one, next slide please. Okay, so this is the advancement for the CCUS fulfillment. So the first one is the advancement in carbon capture technology. So advancement in carbon capture technology help to reduce the cost of capturing the CO2 from industrial processes. The innovative such as solvent-based system have the potential to lower the cost and energy requirement of capturing the CO2. So next is the advances in CO2 utilization. So this helped to create new markets and value streams for capture CO2. For example, the development of new CO2 based products and materials. So the next one is the enhanced storage and monitoring technique. So this helped to ensure the long-term safety and stability of stored CO2. So this can improve the geophysical imaging, modeling, and monitoring technique that can help to increase the confidence in the ability to store the CO2 safely and efficiently. And the next one is the policy support and financial incentives. So this is to help accelerate the deployment of CCUS. Government can provide policy support through tax incentives, grants, and regulations that encourage the development and deployment of CCUS technology. And the last one is the cross-industry collaboration. So the collaboration between different industry, including the oil and gas industry, the power industry, and the manufacturing industry can help to share the knowledge, the resources, and the expertise to accelerate the development and the deployment of CCUS technology. So that pretty much the content of today's lecture. So next slide will be I'll open for the Q&A session. Thank you.
All right, so for our next activity, we'll open the Q&A session. I'm sure all the participants can't wait to ask questions. For those who have questions, you may use the raise hand feature or feel free to drop your questions in the Zoom chat below. Maybe we give a few seconds for them to type it out. All right, so we have our first question. So what do you think should be the focus of development so that the CO2 EOR could be more efficient?
Okay, thank you for the question. So from my point of view, so basically the development for so the COR. Okay, for the CO2 EOR, I'm not too sure for it to be more efficient, but because I think this can be explained by the next speaker because it's the expertise for the CO2 EOR. So basically, from what I understand is like to ensure that the CO2 is efficient is on how much the CO2 can react, like how the CO2 can actually replace the remaining gas or oil that is being left on the reservoir. That basically I think there's a factor that can actually contribute into that, on how the CO2 properties can actually involve in extracting the oil and gas. So I guess it depends on the CO2 properties that we can control, I guess. So I'm not too sure. So I guess from my point of view, it would be the CO2 properties on how you can control the CO2, maybe the injection rate, the CO2 viscosity, or the pressure and the temperature. Basically, the CO2 properties lah. Basically, on how CO2 properties can efficiently reduce can efficiently enhance the oil recovery. Yep.
All right, so we have another question here. Is CCS a good topic for undergraduate students? to use as a
Yes.
final year project topic. What do you think?
Yes, that is actually good topic because I just graduated last 2022 April. So basically during my undergrad I have to do my final year project on the end of 2021. So basically I'm the in my batch I'm the only one that doing the CCS project because my supervisor is actually one of the first student in UTP also that do the CCS project. So he is currently the trainer for PETRONAS in our national oil and gas company. So basically, I'm pretty sure that CCS is a topic now because currently in our department, in UTP, the most of the project is about CCS. So it's a good thing if you want to further your FYP in CCS project. So I have listed few, right? The area such as the CO2 containment or CO2 injectivity or the CO2 storage. They are that big areas that you can discover. So as for my research, I am focusing on the CO2 injectivity. So that's basically like a good topic for you to discover what CCS. It's a wide topic to discover as it is a new topic for us in petroleum engineering. So and it is a new transition for the petroleum engineering basically. So I advise you to go with the CCS project.
All right, so we have one more question here. What can normal civilians do to reduce carbon emissions?
Okay, for individual contribution to reduce the CO2 is just a basic one is like you can you apa you can like use more public transport, right? So we are not using our own car because currently is as for our country in Malaysia, most people have their own car and they go anywhere with their own car and this contribute more to the CO2 emission due to the combustion of the fuels. So why not we just carpooling or do the public transportation or another one is like not doing any open burning because I guess open burning is one of the thing that people not taking it seriously. So yeah, that is a pretty simple contribution that we can do as an individual.
All right, so we have one more question here. Do you think petroleum engineers will lose jobs since carbon capture isn't part of their syllabus in university?
Why do you think that way? Because CCS is part of petroleum engineering. Um, because you have to know that CCS a new discovery in petroleum engineering because usually previously we only focus on reservoir like reservoir engineering, drilling engineering or production engineering which related to the gas or the oil only, right? So because CCS is actually part of them which is we also produce from the field, for example in the Kasawari field that we produce from the high CO2 content gas field. So we want to produce from that field, but we have high CO2 content. So how we want to produce? If we want to produce that field, we have to consider the high content of CO2. Due to the policy, we cannot really produce the field that has very high CO2, right? So with this CCS, the introduction, like the implementation of CCS, we can produce the field, and from that we can discover like lots of new field, and that's pretty the need of petroleum engineer is that to be involved in that one because in CCS also we have the CO2 monitoring, CO2 modeling. That's how the role of petroleum engineer has to play part in the CCS as well. So it's just a new department of petroleum engineering. Basically, CCS is a new business in petroleum engineering. So you will not lose any job or petroleum engineer will not be relevant. That is not correct because CCS is part of petroleum engineering. Okay. So
All right. So next question. Which is more efficient, carbon utilization or carbon storage?
Okay, thank you for the question. So, as for me, I would say carbon storage because carbon storage, it can store tons of CO2, right? So, as for example, with the only as for Malaysia, with only two CCS field, we can store the amount 46 tera cubic feet. Can you imagine how big that storage is actually to store our CO2? So due to the advantage, the carbon storage is much more efficient in terms of storage, like reducing the CO2 emission on the atmosphere, because carbon utilization, you need the technologies, or maybe the technology have limitation on how much CO2 can be produced on and how much CO2 can be converted into products, right? So if we convert it into something, you will need like supply and demands, all of that businesses. And I guess the most effective is the carbon storage, which we just inject the CO2 inside the formation, and with the very high capacity of the storage, it can significantly reduce the CO2 emission, I believe.
All right, so for the next question, rather than other utilization, why CO2 EOR is much more preferable?
Oh, why is it preferable for EOR?
Yep.
Okay. I'm not sure if it is preferable, but I think for EOR, because we know, right? When we produce from the field, when we produce, there is some remaining oil or gas inside the formation. So we know also that the CO2 is one of the ways to enhance the oil recovery. So that's why by injecting the CO2 in this depleted gas or oil reservoir, we can somehow make revenue based on the CO2 injection. So somehow we can comply with the net zero carbon emission policy, and somehow we can make a revenue based on the injection itself. So that's how we can profit based on the CCS basically. Because if you think CCS is high cost, right? So how do you profit? Like you think, oh, why we inject? We need money to inject, but like how do we get the money and how we can benefited by this CCS? So one of the way is through the CO2 EOR. So we can make revenue based on the recovered oil and gas from the remaining brownfield, and for example, for the field that is having high CO2 content, we can also produce from that gas field because we already have CCS, so we can just produce and store back the CO2. So that is the business that currently going on with the CCS. So yeah.
Hi, Miss Mutia. I think I have a question.
Okay.
Assuming that in the long term, the demand for oil and gas will decrease, so can existing oil and gas pipelines be converted into CO2 transport pipelines? And how simple is the process of converting it?
Okay. I think for existing pipeline, in order to use it, it depends on the field that we are producing, for example, or depending on where do we want to inject, because the pipeline should be located from the producing field to the injected, right? If you want to do the CCS. So it depends like which field. If for example for Kasawari we have the field and we have already the pipeline, we can just use it. But if there is like a new field or different injection that is far away, maybe we might consider another pipeline, I guess. So to answer like how simple it is, I'm not too sure the process to reuse the pipeline. Maybe we have to consider the materials of the pipeline because now we are transporting the CO2, right? So maybe few things need to be considered in order for you to reuse the pipeline due to the materials of the pipeline or that considering the corrosive CO2 transportation.
All right. So thank you to all participants for your involvement during this Q&A session with Ms. Mutia. Also, thank you, Ms. Mutia, for answering all of the questions. Unfortunately, due to time limitations, there'll be the last question for our Q&A session. Once again, thank you, Ms. Mutia, for your valuable insights and experience. I'm sure all the participants learned a lot from this session. So on behalf of Speak Up 2023 committee, we would like to express our utmost gratitude to Ms. Mutia, who has taken the time and energy to share her knowledge and experiences with us today. We look forward and would be more than happy to work with you again in the future. All right, so here is your e-certificate from us. So once again, thank you, Ms. Mutia, and you may share a word or two as a closing statement for our session.
All right. So basically, I hope my presentation is pretty okay because this is my first time to give a talk with a crowd audience, and I hope my experience in CCS has somehow give you an overview what is actually CCS, and for Malaysian, you at least know what is the current update for CCS in our country, what are the field that is being developed for the CCS. So CCS is an interesting topic. It is a new thing for us for petroleum engineer. So I really advise you to read on the CCS, get to know what is CCS. So if you have any further question related to CCS or CO2 negativity that is related to my research, you can just simply contact me through my LinkedIn or I guess through my LinkedIn. So I hope my presentation today is giving you some inputs, and I'm sorry for any inconvenience that I'm giving throughout the presentation. So that's basically it. Thank you.
Thank you again, Ms. Mutia, for the kind words. Now, participants may turn on your cameras for our virtual photo session to capture today's valuable moment. Maybe we give around 1 minute for the participants to on their camera. I'll pass it to the documentation department.
Okay, I'll be taking the photo in 3, 2, 1. Okay, once again, 3, 2, 1. Thank you.
All right, so that's a wrap for this session. Thank you again, Ms. Mutia, for today, and thank you all participants for your attention and involvement throughout this session. Before we part our ways, I, as the moderator, would like to apologize if there is any misunderstandings and mistakes. Thank you very much for your attention. As for Ms. Mutia, you may leave the meeting, and to all participants, there will be a short 45 minutes break, and please join us by 12:45 Indonesian time before our last session begins. All right, so thank you and see you at 12:45. Thank you.